everyone. Welcome to today's video on finding the complement of a Boolean expression. There are basically two ways of doing it. The first way is to use the De Morgan's law. The De Morgan's law says what? So if there is a Boolean algebraic expression like x plus y, the plus over here is the logical OR operator. Say I want to find the complement of this. So according to De Morgan, this would be x complement dot y complement. This dot is nothing but the logical AND. Similarly, we can say that the x dot y the whole complement can be written as x complement plus y complement. So having said this, say I want to find the complement of function f1, where f1 is given as x bar y z bar plus x bar y bar and z, and I need to find out f1 the whole complement. So that means what? I have to find the complement of this entire expression. So it is not as simple as just complementing each literal, because we need to apply the De Morgan's law over here. So here we can consider this as one literal and this one as my other literal. So applying the De Morgan's, I can say if this is A and say this is B, then A plus B the whole bar is A bar dot B bar, where A is going to be nothing but X bar Y Z bar, and there is a bar over A. So whole bar dot x bar y bar z is b. So let me replace that. X bar y bar z is b. There is a whole bar over b. So this is how we have replaced this expression, removed the whole complement, and we've used De Morgan's to do that. Now we can further simplify this. Here again, if we look at this expression, this is x dot y dot z. It's in that format. So the only difference is that instead of x, it is going to be x bar. So when we write the De Morgan's, uh, apply the De Morgan's law for this, what we get here would be x bar the whole bar plus y bar plus z bar the whole bar. And for the other one, we are going to get x bar the whole bar plus y bar the whole bar plus z. So now when we simplify, we'll get the bar and bar would get cancelled. So it is basically one complement is nothing but 0, and the complement of one complement is 0 complement, which again turns out to be 1. So if there are two complements, it is going to cancel out each other. So that's exactly what's going to happen here. X complement, the whole complement is nothing but x plus y bar plus z, and here we have x plus y plus z bar. So this is what we get when we apply De Morgan's law to find the complement of a Boolean expression. Then what is the second method that I'm talking about? So this is a very simple way. It's a two-step process. The first step is you need to find out the dual for the expression, and the second step is to complement each and every literal in the expression. So every input that is used here, right? X, Y, Z, each of these are literals. So how do we do it? So let me take the same expression. So we have f1 is equal to x dash y z dash plus x dash y dash z, and we need to find out f1 complement. So we complement the whole expression. So the first step is to obtain the dual. So to find out the dual, there are two things we need to remember. The logical OR operator will be replaced by logical AND. The logical and will be replaced by logical or. This is the first thing. The second thing is, if there is a 1 in the expression, it should be replaced by a 0. If there is a 0 in the expression, replace it with 1. So these are the two things which we need to do so as to find out the dual for a particular, any particular Boolean expression. So let's apply this and find the dual for this expression. What we get here is x bar. So there, these are all dots over here and logical ands. So all of them will become logical ors, y plus z bar, and this logical or operator will become a logical and, x bar plus y bar plus z. So this is the first step. The first step is we've computed the dual for this particular expression. Now the second step is to complement each literal. So here we have x bar. So we need to make it as x. We have y. It should become y bar. We have z bar. Make it z. Retain the other operators. X plus y plus z bar. So this is our F1 complement. We can go back and check it out. So if we compare this with this, so this is the expression which we obtained by applying De Morgan's theorem to find out the complement of the Boolean expression. And this one is using the two-step method. The first step is to find the dual of the expression and then complement every literal. Using De Morgan's law to find the complement of very complex expressions could become a tough task, and it might lead to errors. Whereas this two step method is much simpler. So, there you are, you have a simple method at hand, and not worry about applying De Morgan's law to find the complement of any expression. That's all with today's video. I hope it's useful to you all. Please do subscribe to this channel for watching more such videos. Thank you.